Okay, so this is 8.3 geometric sequences and series. On Wednesday, we'll review for test 4, and you'll have Wednesday, Thursday, Friday to take the test, just like our normal sequencing. And then the week after that, next week, Monday and Wednesday, we'll review for the final, and then you'll have Wednesday, Thursday, and Friday to take your final. That's 60 hours in there. The final, oh, good news. I had told you it was, I can't remember if I told you guys or the other class, but the review is 54 questions long. The test is not that long. The test is only 40 questions long. So it's, our normal test is 25 questions. The final will be 40 questions. They're all multiple choice, nothing, new in the format, except for the fact that it's a little bit longer. It will cover everything we did. So, the review will cover everything we did. And out there at my math lab, you'll see 3 different reviews. One has a due date during this semester. The other 2 have due dates of July 4th. So those 2 are just extra if you want to do them. If you want to, practice the final stuff again, you can go in and take another practice test and another practice test. But the ones that are due July 4th don't count for you, don't count against you. They're not, I got a check mark by them out where I get to put a check mark if I don't want to include them in the grading system. And you can tell that they're different because their due date is July 4th, and that'd be silly, So the first review for the final is just like normal. You have to do it on my math lab. It counts as a grade. It counts as a bonus point. Okay, let's get going on 8.3 unless anybody's got anything they need to ask about, wonder about, any of that about. Okay, if something occurs to you, it's fine to just jump in and ask. Okay, we are doing 8.3, geometric sequences. We did do arithmetic sequences last week, and that means where you're adding something in each time. So if you were trying to find a certain term in the sequence, a sub n, meaning any term, any general term, then you start with the first one, a sub 1, and because with arithmetic you're adding, you'll be adding in a certain amount of a number each time. This is called the difference, but it's a number that you'll be adding in, and you'll add it in n minus 1 times. So that if you're looking for the 10th term, you would start with the first one and add in 9 times the difference. We're going to do that same thing with geometric sequence, except turn it into multiplication instead of addition. So let me show you how that's going to work. Let's just jump in. They're going to ask you to write the first 5 terms, of the geometric sequence. They'll give you the first term, just like before. So that's 8. And they'll tell you that the common ratio will be the word when it's geometric sequence. The common ratio is 4. So a sub 1, they told us, is 8. And because this is a geometric sequence, we're multiplying. So a sub 2 will be 8 times 4, which is 32. A sub 3 will be 32 times 4, or another way of thinking of it is 8 times 4 times 4 again. We'll look at that in just a second. We get 128. A sub 4, the 4th term, multiply by 4 again. And then finally, 512 times 4 will give us 2048. Okay, so that's the first 5 terms of the geometric sequence where the first term is 8 and the common ratio, meaning you're multiplying it in, is 4. Let's look at this. This first one, a sub 1 is 8, no problems with that. A sub 2 is 8 times 4. That's what we've done. We've multiplied times 4, or 4 to the first for our purposes here. The third term is 8 times 4 times 4, which is 8 times 4 squared. We're looking for the third term. we'll be multiplying 4 times 4 times the first term. A to the fourth, the first term times 4 times another one. So 4 to the third. And then finally, a to the fifth is the first term times 4 times another one times another one times another one. So the general formula for adding in is, and let's look at the geometric sequence here. We're going to have a sub n equals, we're going to start with a sub 1, and then we're going to multiply in that ratio raised to the n minus 1. So it'll be whatever that common ratio is, 4 raised to the n that we're using, take away 1, because you don't throw it in on the first one, you throw it in one time on the second one. On the third term, you've thrown it in twice, just like we did with the common difference in the arithmetic sequence. So there's the other formula that you'll need to know on the test. So these two formulas you'll need to memorize. The summation ones, no, but the a sub n for both of them you need to know. Okay, let's look at our second problem. Let's do the same thing. Yeah, exactly the same thing. So a sub 1 is 324, and the common ratio is 1/3. We're going to write the first 5 terms of the geometric sequence here. So a sub 1 is 324. A sub 2, we're going to multiply 324 times 1/3. That's the same as dividing it by 3, but let's go ahead and multiply just because that involves that wonderful key on your calculator. So 324 times 1 ABC3 equals, we get 108. The third term will be, again, 108 times 1/3. So I'll just put that's in my calculator right now, times 1 ABC3. We get 36. We're dividing by 3 each time, which is the same thing as multiplying by as reciprocal. Times 1 ABC3 is 12. And then a sub 5 times 1 ABC3 gives you 4. There's the first 5 terms in the sequence, in the geometric sequence, whose first term is 324, and the common ratio is 1/3. Okay, if we'd been looking for only a sub 5, we would have said a sub n. Let's start with the formula. If we were only looking for that one, we'd do a sub 5, that's the one we're looking for, the 5th term, equals, sorry, that should be multiplication right there, equals a sub 1 is 324 times the ratio, the common ratio is 1/3 raised to the 5 minus 1. So we'd have 324 times 1/3 raised to the 4th power. Let's work that in our calculators. I'm just going to do 1/3 to the 4th power. So 1 ABC3 raised to the 4th power. We get 1/81. And then times 324. And that equals 4. Which is what we got. I mean, it should match. But I wanted to show you using the formula. How do we know we have to do? They'll tell you. They will tell you very distinctly, write the first 5 terms. This one would say write the first 5 terms. They're not going to ask you for that. They're only asking you for the first 5 terms. So let me put that right here. Write the first 5 terms, because the next problem is going to ask you a little bit of a switch. They're just going to say, find a sub 7, the 7th term. For, yeah, you're welcome, Chloe. A sub 1 equals 5, and they have to give you these 2 aspects. They have to tell you what you're starting with, and they have to tell you what either the common ratio is for geometric progressions, or they have to give you the common difference if you're doing an arithmetic. So they have to give you both of those. Okay, so let's just find a sub 7. That's what this instruction would look like. So let's see, we've got the formula, a sub n equals a sub 1 times r to the n minus 1. So we're looking for a sub 7. A sub 1, you know, is 5 times the common ratio is 3. We're just filling in all of the variables. There's a variable n, we put a 7. A sub 1 is a 5. The ratio is 3, and then raised to the 7 minus 1. So a sub 7 equals 5 times 3 to the 6th. The seventh term then is going to be 5. I don't know how. Your calculator should do this first, so you should be able to just put it in there. Let's see what happens. 5 times 3, humpy 6. So the calculator does order of operations properly, so exponent should be done first. My worry is that it's going to think 5 times 3 and then raise that, but I'm thinking not. I'm thinking that they can handle that. 3645, good, it did. If you're concerned about it, then don't ask your calculator to do more than one thing. You know, in order of operations, exponents come first. So do 3 humpy 6 and get 729, and then multiply that times 5. You just never know if you're interpreting the thing correctly, that what you think you put into the calculator is what it thinks you put into the calculator. So just watch out for stuff like that. Okay. All right, we are done with this formula. We're now going to use summation formulas, and you're not responsible for them. There's just some cool stuff you can do with summation. Oh, one thing I do want to take you over to before we do that. Let me share my screen. Okay. This is your test for this week for Wednesday, Thursday, and Friday, and I'll remind you of this again on Wednesday when we review. This availability is that it's hidden from students. So if you went to Proctorio and then went to your exams or here, you wouldn't find this yet. You'll find it Wednesday at noon, regular time. But I've thrown in something a little bit different here. Room scan must include, number 1, show the entire room, you know, all the way around, and almost all of you are perfect on it. I'm not having too much trouble at this point. Number 2, show me under your work area, show me your work surface. Number 4, show me both sides of your scratch paper as they sit on your work surface. Number 5, show me your calculator. Okay, scratch paper, this is the new part. You must show work on your problems, on the problems we talked about in the review. So there are a lot of problems in this test that you've got 2, 3 ways of solving. And you're going to have to show me, you're going to have to prove to me, you have to show off that you've learned a new trick, that you're an old dog and you've learned a new trick. So if say it's a system of a system of inequalities, or system of equalities of 2 equations in 2 variables, you know how to do that from the first section, 5.1, where you can add it, or you can substitute it, or you can go and use Cramer's rule. So with the determinants. So the instructions will tell you very clearly what to do. And I know you can do it any of the ways, but you have to prove to me that you're doing it the way I'm asking for it, or I won't give you credit. And I'm going to go and make sure of that. You know, if this were in a normal situation, you'd be filling out reams of paper there, showing me, proving to me stuff, and I'd be grading what you're doing. It would not be a multiple choice test in a non-pandemic testing environment. So this is my way of just making sure that you have learned a new trick. And so many of the problems have specific instructions on them because you have learned, you know, like with 3 equations and 3 variables, do you know how to get it down to 2 Kiefer equations and then work your way down to 1 and then work your way back up? You also know how to do it with Gaussian elimination and back substitution, where you get the 1, 1, 1 in the diagonal column, or diagonal in the diagonal. So you got to know different ways of doing the same thing. And congratulations if you figured out how to cheat on this. You know, you just put all three numbers in and see which it works. That's great. I know you'll know the answer. You'll be able to figure out the correct answer. But I'm not going to give you credit for a problem that you haven't shown me how to do it. So really the purpose of this is not to get the right answer as much as to show me that you've learned a new method of doing the problem. You've learned something in this class. Also make it easy for me to read your scratch paper. It's annoying to have to look around and figure it out and all. You want me friendly when I'm looking at your paper, of course, and then get your scratch to me within 5 minutes of submitting your test. Okay, any questions on that at this point? You might have more questions on Wednesday when we go over the review. Okay, let's go back. Hi, Ashish, good to see you. Always good to see you. Okay. Let's see. Yeah, that's good. Okay. It's trying to focus. Let me get something to focus on. Oh, how much more fun it would have been had we been in the classroom. I know, I love this group, and I just feel like I've missed out on 95% of the interest of how you guys are, of the kind of people you are. Oh well, what are you going to do? Socially distance, keep your mask on, get a vaccine, get through this, get beyond this, move toward moving out of this. Okay, let's look at the sum. We're going to add up a bunch of these numbers. The sum of n number of things is equal to, here's the formula, take a sub 1, multiply it by 1 minus r to the n power, and in the denominator put 1 minus r. We could take ourselves through the derivation of this formula, but we're not going to do that. We're just going to use the formula. We're just going to accept it and use it. So they're going to ask you to find the sum of the first 12 terms, it's a 12 there, of the first 12 terms of this geometric sequence. Let's see, let's make it 4, 8, 16, 32, 64, ... Okay, that's the first 1, 2, 3, 4, 5. That's the first 5 terms, and they want us to add them all up all the way through to 12 terms. So, you know, we could write them down. We could write then, you know, 128 and then 256 and then 1024 and then, you know, 248, 2048. We could do that and then add them all up. Or we could use the formula. Let's use the formula. The sum of 12 of them, the sum of the first 12, equals a sub 1 is the first term listed, that's a 4, parenthesis, 1 minus the common ratio. Okay, so you're going to have to look at it and decide on what is the common ratio. What is happening as they are going from this term to this term. They've added 4 there, but remember that this is a geometric sequence, and so adding 4 doesn't get you there. That's not what's going on. You're multiplying. So what are we multiplying times each time as we go from one term to the next term? So, yeah, good. Charles, do you see your boo-boo there? Do you know when your brain where you made your mistake? Sweet. Okay. So times 2 times 2 times 2. That's what you're looking for, is the common ratio. What is happening each time? So times 2. 2 is the common ratio. That's what we're going to put there. Raised to the 12th power. Now be careful. You're used to exponents being on the outside of parentheses. This one is not. This one's right there on 2, on only 2. Not 1 minus 2 and then raise it to the 12th. This will be 1 minus, and then we're going to have a monster number here. And in the denominator, 1 minus 2. Okay, let's neat this up. The sum of 12, The sum of the first 12 terms will be 4 times, and then use your calculator. Let's see on bottom, 1 minus 2, I can handle that. So let me get a light on this. Let me just glare. Okay, so we've got 2 to the 12th. We're doing 1 minus 2 raised to the 12th power. And again, your calculator will do the exponents before it does subtraction because order of operations is what it believes in. So we get a negative 4095 right there. Then, you know, order of operations says multiply here, so let's do times 4. We get negative 16380. Negative 16380 divided by negative 1. So the sum of the first 12 numbers will be 16,380. And again, it is possible to write them out and then add them all up. So that's all we're doing here is they're getting you to add each of these up. 64 plus 128 plus 256, etc., to get the first 12 added up. That's what we did with this little formula. Okay, let's do that little formula again. Let's say that you save $1 today, and you save $3 on Tuesday, and you save $9 on Wednesday, and you are tripling your savings, because you can see that the common ratio, 1 times 3 will give you 3, 3 times 3 will give you 9. So the common ratio here is definitely 3. They're going to tell you tripling your savings each day. What will you have after 21 days? So what will be the sum of your savings? So let's see, let's use the formula. S sub n is a sub 1 times 1 minus r raised to the n power over 1 minus r. So the sum of the first 21 days of savings, a sub 1, that's what you saved the first day, it's just $1, parenthesis, 1 minus the ratio, you can see it, 1 times 3, remember this is multiplication in geometric, not addition, and it has to be common, it has to be the same thing from there to there as from there to there, and they'll give you a hint, they'll either double or triple it or whatever. But look at it and make sure that makes sense. So 3, and then n, how many days are we talking about? 21 days, and that's inside. That does not look like inside. There we go. Over 1 minus, and then the ratio is 3. So let's see, we've got 1 minus, no, sorry, 1 times. Saving up 21 days worth. Go ahead and take care of that. Got 1 minus 3 caret 21 equals that mess. So that's negative 1.046 blah, 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 blah times 10 to the 10th power. We're just going to leave it in our calculator. The next thing you want to do is you want to multiply it times 1, which isn't going to change anything, but if it did, I mean, if it were not a 1, answer times 1, and you get the same thing, so there's no harm in multiplying it times 1. Now, 1 minus 3 is a negative 2. Let's divide it by negative 2, and there we go. That's the answer that we're looking for. That answer will be not in scientific notation. So let's see what we got here. After 21 days, you got 5,230,176,601. That's money, so put a dollar sign on it. So there's hundreds, thousands, millions, 5 trillion. You can have $5 trillion in 3 weeks. In 3 weeks, that tripling will give you three. It doesn't look like it. 1 and 3 and 9, and then 27, and then times 3 be 81. I know, I know. So if any of you figures out how to make this work, I was thinking, make sure it's legal anyway, and then maybe bring in donuts one day for all of us with your extra savings. So ton of money there, ton of money there. Okay, we're done. That's it on 8.3. We are done, done, done. I got nothing more to offer. I will see you on Wednesday for our review. Stick around if you have a question. Otherwise, oh, wait, don't go anywhere. Let me get, I did not even have a chance or didn't think to take attendance. Let's see, here we go. Bam. Okay, you're good. One, Charles, there's one review that you're doing. The other two are not, they don't count. So the one review, you get 1 point. And I'm kind of stretching it on that. There aren't supposed to be bonus points on the final, but 1 point either way won't kill us. Yes, Ashish, we will review for the final. Next Monday and Wednesday, we'll be reviewing for that final. I think you must have come in a little bit late because I hadn't noticed you when I started. We'll review on Monday and Wednesday. It is a 54 problem review, but the final is only 40 questions. And you'll have 2.5 hours to take it online. It's all multiple choice like you're used to. But we will review, and it's a good review. If you know what's on the review, you will be fine on the final, and there's nothing on the final that's not on the review both ways, you know, like normal. Okay, half-hour class. I'm robbing you of your money, of your tuition money. Don't do that very often, but go back to sleep or go enjoy a coffee or something and have a good morning. I'm gonna cancel this. No, Kate.